All right, guys, so we're into our lesson on energy and conservation of energy. So first, we're just going to start with a basic definition of what energy is. And you guys are probably familiar with kind of the concept of energy, but formal definitions are a little tougher to come by. So we're going to define energy as a quantity that measures the ability to change or move matter. So it allows you to change or move matter. That's what energy does. And so, if you feel like you have a lot of energy, then you can do things. That's basically what it allows you to do. So, the unit for energy is the joule, which is the same as what we established for work, or a Newton meter. They're the same. And approximately 1 joule of energy, or 1 Newton meter, could lift basically one apple a distance of 1 meter up. So just to give you a physical idea. So a joule is not a ton of energy. It's not a very large amount. It is an amount, though. So in general, we define energy into two main groups. We define something as mechanical energy, which is ME, and that's energy that can easily be transferred to change or move matter. Forms like kinetic or potential energy fall into this category of mechanical energy. And then we have non-mechanical energy. So non-mechanical energy, or not mechanical energy, is energy that cannot be transferred easily into doing work. So it can't easily change into move or matter. And things like heat and sound are the types of energy that are non-mechanical forms. Light is another form of non-mechanical energy. So in general, our model for energy works this way. So we have a system or a group of objects, and we kind of decide that those group of objects altogether, they have a total amount of energy that we call TE, for total energy. So when you put all those energies together, that's your system and the total amount of energy in your system. So you have your system, and I have this purple oval around our system, and that is kind of the boundary of the system. So all these things that we might be talking about in a situation, when we put all their energies together, all their energy is contained there. And then outside of the system, or external to the system, there are other things, obviously. So unless we have a system that includes everything in the universe. So if we have things that are outside of our system, they can influence our system. So it can kind of give energy to our system, and that would increase the energy of our system. Or our system could give energy to the external elements, and that would reduce the energy of our system, but it would increase the energy outside of our system. So we'll talk about this idea of conservation later, but essentially the energy that you start with should be the energy that you end with, if there aren't any external transfers of energy or internal. So like you can't put energy in or out. If you don't do that, then this energy would stay the same. So kind of like if I had, 20 joules. So if I had 20 joules of energy and I didn't put anything going out, so if something goes out or in, this number is going to change. So if I add energy in, it would be a plus. If I took energy out, it would be a minus from this energy. But if we didn't have any of those, so like if we didn't have any external kind of changes, we didn't have our energy change going in or out, it just like transferred between these different types, then this total energy that we had in the beginning would equal the total energy at the end. So that's conservation of energy in a nutshell. So just to kind of establish what these mechanical energies are to start, so we have kinetic energy, which you might be familiar with. The word kinetic means motion, so it's energy of motion, and that's Ke. Gravitational potential energy, which is Ug. It's the stored energy associated with an object's height above the ground. Elastic potential energy, or spring potential energy, that's Us. So again, potential energy stored in a spring or an elastic object when it's stretched or compressed. We'll talk about them more later. So we're going to just kind of distinguish between two words that are similar but not exactly the same. So we can talk about energy transformations. So a transformation is like a transformer. It changes. So energy of one kind is going to transform into another type of energy, but it stays within the system. So the energy doesn't go anywhere. It still stays in that same system. It's just changed the form.